Now we have types of triangle. There are two different ways to divide types of triangles. The first one is side basis. Very clearly, if all sides equal, the triangle is called equilateral. Now equilateral triangle is a very important one. If all sides are equal, all the angles will also be equal. So each angle is 60 degree, right? If I say the side is A, right? What are the important things about equilateral triangle? So directly, area of equilateral triangle, that is root 3 by 4 into a square. Now till now we haven't talked about area, but I want this to be remembered because we are revising, right? So order is not that important. So area of equilateral triangle, very clearly root 3 by 4 a square. Okay. Height of equilateral triangle. What is height of equilateral triangle? Perpendicular from one vertex to the opposite side. This height is root 3 by 2 into the side. Okay. And similarly, the circumradius of equilateral triangle is side divided by root 3, and in radius of equilateral triangle is side divided by 2 root 3. So these things should be remembered as it is directly the moment it comes to the moment you hear the word equilateral triangle. These four things should immediately come to your mind. What is capital R? That represents the radius of the circumcircle that passes through all three vertices. So what I'm trying to say here is, whether you are good in geometry or good in triangles or not, when I say equilateral triangles, these four calculations should be absolutely clear in your mind. So radius of this larger circle is capital R, that is a by root 3, and radius of the smaller circle is the small r, this one, that is side by 2 root 3. The center of both these circles is at the same point here. Okay, this is the center of this, the circumcenter as well as the incenter. That is for equilateral triangle. So this equilateral triangle has to be treated as a special case, and everything should be remembered. Whether you are good in geometry, whether you are good in triangle or not, there is no question about missing on this in any manner. And obviously the other two types, very simple. Isosceles is the triangle in which exactly two sides are equal. Okay, there is no overlap. Be very clear about this. Exactly two sides equal. The third sides not equal. Okay, third side should not be equal. Only two sides should be equal. And obviously the angle opposite to the equal sides will be equal. So this angle and this angle will be equal, right? There's nothing more about isosceles triangle right now. We'll come back to this at a later point. And the third type is scalene triangle. Scalene triangle means no sides equal, or all sides different. All sides different. Okay, that's it. Now, angle basis. There are three different types. I'll start with the right angle triangle actually. Okay, on the first one, it is, as per the importance, right angle triangle. So the way we had equilateral triangle as a special case, similarly in angle basis, right angle triangle will be taken as a special case, right? Everything that is related to a right angle triangle should be remembered as it is directly. What all things do we have? So right angle triangle means one angle should be 90 degree, and anyways in a triangle you can have only one angle 90 degree. Or maybe no angle 90 degree, that is okay. But you cannot have more than one angle 90 degree in a right angle triangle. Okay. First of all, area of a right angle triangle is equal to half into product of perpendicular sides. So if I have the perpendicular sides as A and B, then half into A into B. Right. Secondly, the circumradius of the right angle triangle, circumradius of a right angle triangle is equal to half of hypotenuse. Once again, the same dialogue I'll put. Whether you are good with geometry, whether you are good with triangles, doesn't matter. Right angle triangle, these properties should be absolutely clear the moment you hear the name. Okay. In radius of a right angle triangle. In radius of a right angle triangle, that is A plus B minus C by 2. Okay. So these three things about a right angle triangle should be absolutely clear. I hope you understand. The circumradius is the radius of this circle that passes through all three vertices. In radius is the circle that touches right? And so on. You can see this point is the center of circumcircle, and this point somewhere will be the center of incircle. That will come back into in details also, but for calculation purposes, for idea purposes, these three things should be absolutely clear the moment you come across a right angle triangle. There may be other properties also, but these are the primary things that should flash. The moment you hear right angle triangle, does it flash? That's the important thing. Now there are certain right angle triplets which are also called Pythagorean triplets. I mean, we all know the Pythagorean theorem, Pythagoras theorem for right angle, right? That is a square plus b square equal to c square. Following this, there are some special cases or triplets that we should simply remember, or rather we should know, like a family name. There are triplets that we should know, that is 3, 4, 5. Okay. Now this is a very important point to understand. If the ratio of the sides is 3:4:5, it is definitely a right angle triangle, right? So whether it is 6, 8, 10 or anything else, or any multiple of 3, 4, 5 or any factor of 3, 4, 5. If there are two sides which are in the ratio 3:4, like say 39 and 52, and if it is mentioned that these two are the smaller sides of a right angle triangle, then the third one is clearly what? You see the ratio 13 3s are 13 4s are. So this should be 13 5s are 65. Obviously, it should be mentioned right angle triangle. And so on and so forth. So I'll just mention the triplets. 3, 4, 5 is one triplet. Okay, an important one. 5, 12, 13, an important one. Okay, 7, 24, 25, this is an important one. 8, 15 and 17, this is an important one. And sometimes 20, 21, 29. So there are millions of Pythagorean triplets. The most important one, I feel, it is 3, 4, 5 and 5, 12, 13. And the others sometimes have been used. Every triplet has one specific number which is pretty popular either or important in any ways. For example, 5, 3, 4, 5 is the simplest one. 5, 12, 13 has a prime number 13. The multiples of 13 will be quite visible. Multiples of 7 and 25 will be quite visible clearly. 17 is a prime number, a stubborn prime number. 29 is a stubborn prime number. So the moment you see some combination like this, it will help you to gauge the answer directly. Okay. So these are some triplets that you should know about right angle triangle. Then the second one is obtuse or acute angle triangle. I'll put them directly. Acute angle triangle. What is important in acute angle triangle is to understand that each angle should be less than 90. Each angle should be acute. Okay. And third one is obtuse angle triangle. Obtuse angle triangle, which means one angle is more than 90 degree. Okay. Now if there is a triangle ABC, let's say it is ABC, I'll simply put it like this. If a square plus b square is equal to c square, then what does it mean? It means angle opposite, I wanted the sides to be ABC. Now here I want to point out something really important about a triangle. If there is a triangle, let's say if it is triangle ABC, right? And this is side A, this is side B, this is side C. Listen to this very carefully. I want to identify which triangle is right angle, which angle is right angle, which angle is obtuse, or which angle is acute. What do we need to do? Randomly, simply if you see, if I have a square plus b square equal to c square, that means the angle opposite the side C. Angle opposite C. And what is it? It is angle opposite C is angle C. This means angle C is right angle. That's what it means. If I have a square plus b square, if I have a square plus b square greater than c square, what does that mean? That simply means that angle opposite C, that is angle C, is acute angle triangle. Acute angle actually. Okay. And if I have a square plus b square still less than c square, what does this mean? Clearly angle opposite C, okay, that is angle C is obtuse. I hope this is clear. The order is important here. Randomly if I have, let's say b square plus c square, if it is less than a square, what does that mean? B square plus c square less than a square, that means angle opposite A. angle opposite side A. And what is it? Angle A. And that would be obtuse angle. I hope this is clear. If I say C square plus A square is greater than B square, what does it mean? It means very clearly the side opposite B, the angle opposite B, which is angle B, and greater than B square, it means it is acute angle. So this is how you analyze the type of angles within a triangle. All right. Now the next thing that we have is the area calculation of a triangle. Basically, we need to know the formula, right? For any triangle, the area is equal to simply half into base into height. Okay, half into base into height, right? So for example, if I have this side as, let's say, small a, this side as small b, and this side as small c, right? If I'm taking side or the base as a, then the height that I need to consider is the perpendicular on a, that means from this one. So if this is h1, it is half a into h1. Please be very careful about it. For example, if I take the side b, base b, then height would be on b, that means this perpendicular. Okay, let's call this h2. So this is into h2. If I'm taking base as c, then the height will be on c, that means this length we are talking about. This is h3. Okay, so it is, and from here you can see that all these three are representing the area of the same triangle. That means they're all equal. So a into h1 is equal to b into h2 is equal to c into h3. That also means that the sides are inversely proportional to the heights on them. Okay, so this is one very important relation of sides and heights, sides and altitudes, right? Be very clear. Side is inversely proportional, side length is inversely proportional to altitude length. Okay, their product is constant. So this is the general formula of area of triangle, the most common, most general formula. We don't have to get into the derivation of this. Interestingly, one point you can see that the perpendiculars are concurrent. Anyways, we'll talk about that when we talk about orthocenter. Right, so this is the general formula for area of triangle. This is the first one. Second one, suppose if I am not able to get to the length of height, then there is another way of calculation of area of triangle, and that is, if I have, say this is side A, B and C, this is angle A, this is angle B and this is angle C. If I know two sides and the angle included, for example, if I know angle A, then area can also be calculated as half B into C into sine A. Please be careful, sine is that trigonometric ratio, okay? Sine A. So if A is 60 degrees, sine 60 degrees, root 3 by 2, that ways. That means it can also be taken as half AB sine C, or it can also be taken as half CA sine B. Please note that whatever two sides you take, you have to take sine of the angle included, right? So this is another way of calculation. And then the third one, the most common one, when the angles are not known and only the side lengths are known, okay? And no type is identified, that is called Heron's formula, right? That is the most popular one actually. And this says if there are sides of triangle, that is A, B, C, then straight away the area is calculated as square root of S into S minus A into S minus B into S minus C. I'm sure all of you are aware that S is equal to A plus B plus C by 2, and it is semi-perimeter. Okay. Now here only I'll also mention the circumradius usage and in radius usage in terms of area of triangle. So very important. Fourth one, if I know a triangle and if I know the length of sides as well as the length of circumradius ABC, and suppose the circumradius is R, then area of triangle can also be calculated as product of sides divided by 4 times the circumradius, right? So actually this is not the formula of area. We calculate circumradius from here, right? And that is product of sides divided by 4 times area of triangle. Okay, just be very clear about this. Similarly, fifth one, and that is if I have a triangle and if there is an incircle in the triangle, and suppose the sides are A, B, C, and the radius of incircle is R, then area of triangle can be calculated as semi-perimeter into in radius. Now using this, actually we can calculate the in radius, and that is in radius of any triangle is equal to area of that triangle divided by semi-perimeter, right? So just keep this in mind. So we use actually these two formula from here to calculate the circumradius and in radius in the general cases, right? We already have seen a couple of specific cases like equilateral triangle and right angle triangle. Here we are saying that for any triangle, if you want to calculate circumradius, use the product of side divided by 4 times area of triangle. If you want to calculate in radius, use the formula area of triangle divided by semi-perimeter of the triangle, right?